Hello all and welcome to Physics 111. In this first lecture, I'd like to tell you a few things about the course in general and about our plan. And then I will start discussing chapter 1. Ideally speaking, I expect you to come to the lecture prepared. I expect you to check the review that is posted on Blackboard for the chapter, and also to read the material and to use the time here for discussion, for learning together. So the first part of each lecture will be a couple of multiple choice questions, 4 or 5 questions, and checking your understanding of the things that you prepared, and then we move formally to the lecture. I will have each chapter discussed in one lecture. The lecture will start at this time every week, and it is open-end. We will continue together. Shouldn't take more than 1 hour and a half, maybe 1 hour, depending on the chapter, on the material, on the number of students. We will be able to discuss the material and learn about the subject. The lecture should be recorded and posted on Blackboard Collaborate Ultra for students who will not be able to join us. After all, this is a synchronous environment, but I thought to help you, I will also add some synchronous, some interactive lectures to the course. So, since this is the first lecture, you may not have the chance to prepare to go to the material. Therefore, I understand this part, but starting next week, I expect you to come prepared and to be better involved with the discussion of the multiple choice problems that are in the introduction. So what is physics? When we study physics, what we are doing actually? When we study physics, we are doing measurements. Most of the time, when we study physics, we are trying to understand something, how it changes its position, its velocity, its energy, and so on and so forth with time. So physics is about measurements. What we see here in this first slide, I will put the PowerPoint on the screen, okay? What we see here is numbers. The speed limit is 50 miles per hour, which is the same as 80 kilometers per hour. As you can see, we are talking about a speed represented by a number and by a unit. The number is 80, the unit is kilometer per hour. This is using metric units, or this is equivalent to 50 miles per hour. This is just an example of physics. So usually we try to understand things around us, we try to measure it, and to express the measurement using numbers and units. This is a summary of physics. This is what we do in physics. Few questions that should help us to understand this game. Which of the following would serve as the best time standard? So when we talk about quantities in physics and measurements, we need to use units that are agreed upon by everyone in advance. When I say kilometer per hour, when I say 1 hour, everyone understands what I'm talking about. I am using standards. Mile is a standard of length. Kilometer is a standard of length. Hour is a standard of time, and so on and so forth. So for any unit to be accepted, it has to be known and it has to be agreed upon in advance among all people in the world. Now, with this in our background, let's go to this first question. Which of the following would serve as the best time standard? The rotation of Earth on its axis, the vibration of a cesium-133 atom, a grandfather clock, the buzzing of mosquito. Each one of these represents some time period. But in order to use one of them as a standard, it has to be fixed. It has to be reproducible. Whether you did the measurement here or whether you did it in another country, in another planet, it has to be the same. So this does not apply to a grandfather clock. It doesn't apply to a buzzing of a mosquito. The rotation of Earth on its axis, this also changes, depends on where do we stand on Earth. The one unit that is fixed wherever we are is this one, number 2. The vibration of a cesium-133 atom. This is fixed. No matter where you try to check on the period for this vibration, it will always be the same. So we use this as a reference when we measure time. Then another example for measurement. Suppose that you measure the position of a chair using a meter stick and you record the distance of the center of the seat from the wall. Which of the following measurements is the most reasonable? 1.0438605642 meters. This is impossible. Using a meter stick has dashes on it, is graded with centimeters, with millimeters, but it cannot give you that kind of precision. The same applies here. Then for number 3, 1 meter. Yeah, with a meter stick we can do better than that. 1.04 meter. I will choose this one. Yes, with a meter stick you can measure centimeters. So this is 4 centimeters. Therefore, this would be a more reasonable number using this kind of instrument. So each situation, when you do a measurement, has its own limitation that we need to recognize and to understand in advance in order to do a good work in our measurements. Another example. Which of the following statement is correct? So here we are talking about dimensional analysis. Just like I said, the speed is measured in kilometer per hour or miles per hour. Mile or kilometer, these are dimensions of length. Hour, this is a dimension of time. We use dimensional analysis, as we will learn later in this lecture, to check on equations whether they are valid or not. So let's read. If an equation is dimensionally correct, it must be true. And if it is not dimensionally correct, it may be true. I will not select this. If an equation is dimensionally correct, it may be true. And if an equation is not dimensionally correct, it may be true. This is contradiction. It's not valid. If an equation is dimensionally correct, it may be true. And if it is not dimensionally correct, then it cannot be true. Yes, this makes sense. This is consistent. For if an equation is dimensionally correct, it must be true. And if an equation is not dimensionally correct, it cannot be true. Here, I will not choose this because it says must. This is not always the case. As we will see, sometimes dimensionally correct, but there are factors in the equation. So number 3 is the more appropriate answer. It may be true, yes. And if it is not dimensionally correct, then it cannot be true. So this would be the right choice. Then when we report about our measurements in physics, quite often we'll be dealing with very small numbers or very large numbers. Either way, we use prefixes to help us represent the quantities. Like this case, which of the following expresses 5.2 by 10 to the minus 5 seconds correctly using the metric prefixes given? You see here samples of these prefixes, like 10 to the power 3, it means kilo. 10 to the power 12, it means tera. On the other extreme, 10 to the minus 15, it means femto. 10 to the minus 6, it means micro, and so on and so forth. These are used usually in physics. So this is not kiloseconds. This is a fraction of a second. So K means kilo, which is 1,000 seconds. So obviously this is not correct. 0.52 milliseconds. This is not correct. Milli means 10 to the minus 3. 52 nanoseconds. Nano means 10 to the minus 9. Okay. Again, this is not correct. So this would be my best choice. It is 52 microsecond. 52 microsecond. Micro, 10 to the minus 6. When you multiply by 10 here, you need to divide by 10. So this becomes 52, and this becomes 10 to the minus 6, which is microsecond. The last of these questions, suppose that two quantities A and B have different dimensions. Determine which of the following arithmetic operations could be physically meaningful. We are talking about two quantities that have different dimensions. Can we add eggs to oranges, like adding A to B, say A number of eggs, B number of oranges? The answer, of course, no, you cannot add two different things. It has to be the same thing that you add. The same can be said for 3. You cannot subtract things if they are different, but you can divide and you can multiply. Yes. Okay. So in this case, we will choose this and that. When you have different quantities, you cannot add them or subtract them, but you can divide them or multiply them. So when we report about measurements, we deal with fundamental physical quantities, length, mass, and time. Here we have some examples of lengths that we measure, like the distance traveled by light in 1 year is 9 by 10 to the power 15 meters. Like the radius of Earth, it is 6 million meters, 6 by 10 to the power 6 meter. Like the atomic nucleus, the diameter is 10 to the minus 14 meters. The diameter of the proton, a fundamental particle, is 1 femtometer, which is 10 to the minus 15 meters. So we need to be familiarized with this kind of measurements, and we need also to get familiar with these prefixes that usually we use to report about the measurements. For mass, this is the standard of mass in the SI system. Before 1965, different countries will have their own unit systems. In 1965, the scientific community have an international meeting in Paris, hosted by UNESCO, where they agreed on the accepted system of units that is used by the scientific community since then. So for length, we have the meter in the SI system. For mass, we have the kilogram. This is the standard of mass here, 1 kilogram. We use that standard to represent various masses. So here you can see a typical mass for a human is 7 by 10 to the 170 kilogram. The mass of Earth, 6 by 10 to the power 24 kilogram. The mass of an electron is 9 multiplied by 10 to the minus 31 kilogram. So the unit that we use is the kilogram, and there is the multiplier, as you can see here, that will allow us to express any mass, any measurement. The third fundamental quantity when we do physics measurement is time. And here the standard of time in the SI system, the unit of time, is the second. Okay, 1 second is the standard of time. So here some examples. In 1 day, there are 9 by 10 to the power 4 seconds. A typical radio wave period is 1 microsecond. For nuclear collision, typical value 1 by 10 to the minus 22 seconds. Just to give you an idea about the scale of things that we measure when we use time. This is the image of the cesium clock that is used as a reference for time. Now, a few words about matter. If you take this piece of gold and split it into 2, the mass will be less for each one of them, but the chemistry will remain the same. The structure in each one will remain the same. If you keep dividing these segments into smaller and smaller and smaller parts, at the end you will get to the point where you cannot divide it any further. That is the limit for the so-called atom. Okay, so atom is the smallest amount of matter. Inside the atom, you will see particles, you will see neutrons and protons. Okay, so here protons are the orange ones, and neutrons are the gray one. And if you use high energy accelerators to break down protons and the neutrons, you will find inside them 3 particles which we call quarks. So protons and the neutrons are formed using quarks. Then a group of atoms here will give us matter. So it's good to have this understanding about the universe around us. Atom is the building block of all things. Each atom will have at the center a nucleus, as you can see. Inside the nucleus, there are neutrons and protons. And around the nucleus, there are electrons rotating in specific orbits. Collection of atoms will create matter. So here we have to learn also about approximation. So this is approximate values of some measured lengths, like the distance Earth to Moon. We round the numbers. It is approximated by 4 by 10 to the power 8 meter. You see the unit used for length is meter. The size of the hydrogen atom is 10 to the minus 10 meter. The size of the proton is 10 to the minus 15 meter. So it is always good to be able to use this approximation when you describe things. This is the fundamental building block for protons. We have 2 up quarks and 1 down quark. For neutrons, we have 2 down quarks and 1 up quarks. Protons and the neutrons are at the center of each atom inside the nucleus. When we do measurements, it is convenient to do dimensional analysis. It helps us to check on the equations, whether they are valid equations or not. So for length, when we measure length, the dimension is L, the unit is meter. This is in the SI system. Like for area, you have L multiplied by L, it is L squared. This is the dimension. The unit in the SI system is meter squared. Before the SI system, there was the CGS system. Length was measured in centimeter squared. There is also in the US system, you have the foot squared. For volume, dimension is L cube. SI units is meter cube. For velocity, the dimension is a dimension of length divided by a dimension of time. For acceleration, it is dimension of length divided by dimension of time squared. So when we have this understanding regarding the dimensions, we can use this information to check on the validity of equations. So for velocity, we expect dimension of length divided by dimension of time. So these here will help us, will guide us to check on equations whether they are right or wrong. So here velocity, it is dimension of length divided by dimension of time, or dimension of acceleration, length divided by t squared multiplied by time. Again, it is the same thing. So acceleration multiplied by time, yes, based on this analysis, this is a valid equation. Velocity can be calculated from the product of the acceleration by time. Okay, so now based on the dimensional analysis, we can verify that this is a valid equation. For x, it is dimension of length, so we can have it when you have length then time divided by time. Okay, this means if you take velocity and multiply it by time, velocity is length per time, multiply it by time, cancelled with t, so you have L in the right side. So yes, this equation is a possible equation. You take AT squared For A, it is L divided by T squared. So dimension L divided by T squared here, multiplied by T squared. So you end up with L. So both VT and AT squared are accepted for measuring X. So when you have an equation for X, in the left side and in the right side, you have something VT, something AT squared that is valid from the dimensional analysis point of view. So here, if you say X equals half AT squared, yes, AT squared, this is dimension of length, so this is accepted. And half here is just a multiplier. We move on to significant figures. When we do measurements, as I said earlier, we deal with numbers, we deal with units. So here, if we are trying to calculate the area, say the width is 4.5, the length is 16.3. The precision in the meter stick, you can measure up to 1 millimeter, which is 0.1 centimeter. So I will use this equation to represent the measurement and including the possible error. By the way, the first lab experiment is about error analysis, error and uncertainties. For the first lab, you don't need any material from the lab kit. All what you need to do is just download the handout from week 2 folder, read the handout, understand all about precision, accuracy, percent error, etc., and start working on your lab report. You don't need any material from the lab kit. You can start working on it immediately. So here, this is the error. This is also the error when we measure the width. Now, if we want the area is the product of length by width. We have this answer. And here, when you have this answer with 4 digits, we know from this, we have just 2 digits. So having 4 digits in the answer does not make much sense. We need to round this. When you do the rounding, anything 5 or above, you can increase this by 1. Anything less than 5, you just ignore it. So this would be 73 centimeter squared. So here we have 2 significant figures. 2 significant figures, and therefore the answer 2 significant figures. Now, to tell me that your calculator gave you all kinds of digits here, that's fine. But from the physics point of view, we don't really care about these extra numbers. So you need, when you study physics, you need to understand this game of significant figures, and when you report about any measurement, you need to apply it. This is one significant figure. We don't count the zeros. This is 2 significant figures. You have 2 digits that are significant. So what will be the number of significant figures here?
4.
Okay, any other suggestion?
2.
Yes, it is 2. Thank you. Yeah, we don't consider the zeros this way. So yes, this is 2 significant figures. Look to this now. When you see 1.500, this means we have 4 significant figures, because these zeros could be anything, could be changed. Okay. Here, when you see 1.50 by 10 to the power 3, this would be 3 significant figures, and 1.5 by 10 to the 2, this would be 2 significant figures. Sometimes it's a little bit tricky, but you need to check. When you see the decimal point, it's different than when there is no decimal point. Like here, 3.00, this is 3 significant figures, while this one, 300, and it is just 1 significant figure, because we don't have that decimal point. So this is only 1 significant figure. When you add or multiply or subtract, you need to keep this in mind. and usually the result should contain the number of significant figures. That is the same number. When you have here the original numbers, you take the smallest number of second figures, and that would be the reference for you. So if you add 123 to 5.35, the result is 128.35. We have three significant figures, 1 to 8. So I drop 0.35 because you cannot round this to 1. Okay, and I need just I need just 3. Okay, so the sum would be 1 to 8. That would be the final answer. You just drop the 0.35, and this would be your result, 1 to 8. Subtraction, the same game. So here we have 4 significant figures. Therefore, the answer also has 4 significant figures. Multiplication, when you multiply this by that, then divide by 1.57. So here we have 3 significant figures. Therefore, the answer has 3 significant figures. So we round the digits here. We drop the 4, we drop the 2. Okay, just 13.8. Then divide by 1.57. Again, we have 3 significant figures. Although the calculator told us it is 8.7898, we only care about 3 significant figures. So you round this. Yes, 8, 9 can be rounded. So now it is 79, 8.79. That would be the answer. Okay. Alternatively, you may do it this way. You may start first dividing 5.89 by 1.57. You have 3.7516. Again, 3 significant figures, 3.75. Then you take this, multiply it by 2.35. You get 8.8125. You round it to 3 significant figures, so it is 8.81. So you see, sometimes the number, the final answer, depends on the way we did the rounding, depends on the way we did the calculations. Okay, this is a third method that will produce at the end 8.835, which can be rounded to 8.84. So when we solve the problems, myself, an instructor, when I grade the answers for students, usually I expect this kind of tolerance, this kind of variation in the last 2 digits, okay, due to the significant figures and how the student did the calculations. Now, another important topic when we do measurements and report about it is the conversion of units. Usually there's a table in any standard physics textbook that tell us about the units and how to convert from one system to another. Like 1 mile is equivalent to 1609 meters, which is 1.609 kilometer. 1 foot is 0.3048 meters, which is the same as 30.48 centimeters. 1 inch is 2.54 centimeters. 1 meter is 3.28 foot. We will need this kind of factors when we solve problems to convert from one system to another. For example, convert 15 inches to centimeters. We know that 1 inch is 2.54 centimeters. So we have this factor, 2.54 centimeter divided by 1 inch. This is unity. This is 1, because 1 inch is equivalent to 2.54 centimeters. As you know, in mathematics, we can always multiply by 1 or divide by 1. So we will use this conversion factor to answer this problem. 15 inch, okay, I multiply by 1, this factor here. Inch cancels with inch. So I end up with 15 multiplied by 2.54, which is 38.1 and now the unit is centimeter. Okay, and we have the right number of significant figures in both right and left side of the equation. When we report about measurements, quite often we will be asked to report applying the order of magnitude. So within a factor of 10, 75 kilogram, you will report that as 10 to the power 2 kilogram. Okay, this is the order of magnitudes. Order of magnitude means the power of 10. So the closest to 75 is 10 to the power 2. Another thing that we deal with when we study physics and deal with variables is the coordinate system. We use the coordinate system to describe the location of objects. In this case, this is called Cartesian coordinates. You have the horizontal axis, we call it the x-axis, the vertical axis, we call it the y-axis. So now each point on this graph will have its x-coordinate and y-coordinate. Like this point P, it has 5 for x, 5. So this is 1, this is 2, this is 3, this is 4, this is 5. So x equals 5 and y equals 3. Y equals 3. 1, 2, 3. Okay, so this point has this coordinate 5 and 3. This point, on the other hand, x is negative because this is 0. Anything to the right of 0 is positive. Anything to the left of 0 is negative. Also, anything up is positive for y. Anything down is negative for y. So this point has x negative, minus 3, and has y positive, which is 4. Okay, always when you list the coordinates, you start with x, then go to y. So even if I did not tell you about this sequence, you should understand that the first number refers to x, the second number refers to y. Another way to describe the location of objects is to use the so-called polar coordinates. So that was Cartesian coordinates, which has x and y and z in 3 dimensions. This is called polar coordinates, which has r and theta in 2 dimensions. If you go to 3 dimensions, you will have a third angle called phi. So to describe the location of this point, I will need the radial distance from the origin, this distance r, and I will need this angle between this line and the horizontal, which is usually taken to be theta equals 0 as a reference. So if you know the angle theta and the length of r, you should be able to locate this point in a unique way. Another thing that we need to review quickly, since I assume you have your math background at school, is the trigonometric functions. 3 important functions which we use in physics when you solve problems. The sine function, we define the sine for the angle as the ratio between the opposite and the hypotenuse. So the ratio between y and r, this is called sine the angle. The ratio between the adjacent and the hypotenuse, x divided by r, this is called cosine theta. The ratio between the opposite and the adjacent, y divided by x, is called the tangent of the angle, tan theta. Okay? These are basic trigonometric functions. Usually, scientific calculators will allow us to get the values for various angles, what are the sines, what are the cosines, and what are the tans. Another important formula that we use is the Pythagorean theorem. So here r squared equals x squared plus y squared. The angle here is 90 degrees between x and y. Y is always perpendicular to x. So this is a right angle triangle. For such a triangle, the hypotenuse square is equal to x squared plus y squared. Example, if sine theta is 0.866, what is theta? From your calculator, you click on the inverse button, which will give you the sign inverse. You key in 0.866. The calculator will give you the answer. Theta is 60 degrees. Another example, if you have the tan of the angle, the problem tells you that the angle has tangent equals 0.4. You use the tan inverse function, so you get the value of the angle. It is 21.8 degrees. We move on to vectors. Physical quantities that we measure can be categorized into two main classes, vectors and scalars. Some quantities, you cannot describe them with magnitude only. You need also to specify the direction. While some other quantities, it is enough to just talk about the magnitude. The ones that require direction information are called vectors. The ones that do not require direction information are called scalars. So we always deal with scalars or vectors when we have physical quantities. For example, mass is a scalar. It doesn't have any direction. Temperature also is a scalar. On the other hand, velocity is a vector. If I tell you the velocity is 50 miles per hour, I need to tell you in which direction so that you understand where this object is moving. Is it moving north, east, south, southwest, whatever? You need to know the direction. However, the magnitude of the velocity is called speed. The magnitude of the velocity vector is called speed. Speed is a scalar. Speed is a scalar. So in general, a vector quantity is characterized by both magnitude and direction, while a scalar quantity is characterized by magnitude only, no direction. Both vector and scalar quantities will require units. So in addition to what we said here, we need to keep in mind that physical quantities always need units. In this slide, we see a group of vectors. These vectors have the same length, the same magnitude, and they all point toward the same direction. Because of that, these four vectors are identical. These vectors are identical. So shifting the vector from one place to another, as long as you are not changing the direction or changing the magnitude, will not change the vector. Now, how to add vectors? Suppose we have a vector A and another vector B. For example, a car is moving along this direction, this vector distance, then it moved, changed direction and moved along this path here. So the question, what is the resultant change in the location of the car? To answer that question, this would be the result. The resultant is vector A plus vector B. To add vector B to vector A, you put the bottom of vector B at the tip of vector A this way, and then you close this from the bottom of vector A, this is the starting point, to the tip of vector B, this is the final point. So this will give us the displacement. So this displacement R is equivalent to having these two displacements, A then followed by B. This is the same as saying vector B this way and vector A that way. Again, the resultant is the same resultant. As you can see, this vector is the same as this vector. So B plus A is the same as A plus B. We call this addition of vectors graphically. So you draw the vectors with the proper directions using protractor and proper length. You will use a meter stick. So this way you can predict the resultant for these two vectors. Here we have four vectors. Displacement A followed by displacement B followed by displacement C followed by displacement D. What is the net displacement? The answer, you connect one vector from the starting point, this is the starting point, to the final point. So this vector is equivalent to A plus B plus C plus D. In plain English, if you are talking about an object moving along these four displacements, it is the same as if the vector moved directly from the start point to the final point along this displacement. Because of that, R is equivalent to A plus B plus C plus D. This is another example about vector additions graphically. Now, subtraction of vectors. Subtraction is a special case of addition. If you understand addition, you should be able to do subtraction. So if you have A minus B, this is the same as saying A plus a vector called minus B. Okay? So if this is B, then minus B is just a vector in the opposite direction. This is the meaning of the minus sign. The direction is reversed, but the magnitude is the same magnitude. So now you are adding A to minus B. This would be the resultant. This would be the resultant, A minus B. Straightforward. Okay? This would be the resultant. Now, multiplication. We learned about addition, subtraction, and now multiplication. Say this is vector A. If you want 3A, you just maintain the same direction, just change the magnitude. So the length of this arrow is 3 times the length of this arrow. In this case, this vector will be 3A. If you want minus 3A, means you need to multiply by 3 for the magnitude, and for the minus sign, you need to reverse the direction. Okay, so this is minus 3A. Very simple. Now, if you have two vectors, A and B, okay, 12 units and 8 units respectively. So A is 12 and B is 8. What are the largest and smallest possible values for the magnitude of the resultant vector? I need your help. Suggestions. Any suggestion? What would be the maximum magnitude that you get when you have 12 and 8?
20 and 4.
Thank you. Perfect. Yes, 20 and 4. So maximum when they are aligned along the same direction. You start the displacement A, then you continue the displacement B along the same direction. This way, the total displacement would be 12 plus 8, which is 20. The minimum, on the other hand, it would be as if you have the first displacement in one direction, then you went backward in the reverse order, so it would be 12 minus 8, which is 4. Yes, so these are the correct answers. We move on to another method that we use when we add vectors, which is to use the analytic method. This is called the analytic method for vector addition. So each vector, like this vector A, can be decomposed into two components, X and Y. This is the X component. We can calculate it using trigonometry. AX equals A, magnitude of A multiplied by cosine theta, and AY equals A multiplied by sine theta, because this length is the same as this length. So from this triangle, this length AY is equal to A sine theta. So we can express A in terms of these two components. The magnitude of AX, we know it, AX cosine theta, the direction is along X, and for Y, the magnitude is A sine theta, and it's along the direction of y. This is useful when you have many vectors to deal with. It's easier than graphing. You don't need to use protractor and meter stick. You can do the work mathematically. Okay. So you need just to take note of this, how we calculate AX, how we calculate AY using trigonometry, and you apply the same principle for any other vector if you are trying to decompose them. And you can always go backward. The resultant A is equal to square root of AX squared plus AY squared, applying the Pythagorean theorem. And the direction theta is equal to tan inverse AY divided by AX. So this way you can determine the resultant, and also you can determine the direction of the resultant. So whether you have the vector in terms of its components or whether you have it in terms of its full length and direction, either way, you know how to relate them to each other and how to move from one representation to the other. Okay. This is just to tell us that AX is A cosine theta when theta is taken between the vector and the x-axis. But if you take theta between the y-axis and the vector, then AX is A sine theta and AY is A cosine theta. Okay, so you need to be aware of this. When we say AX is A cosine theta, this is if theta is between the x-axis and the vector. Okay, keep this in mind when you decompose vectors. In this figure, we have two vectors lying in the xy plane. What are the signs of x and y components? Okay, so if you decompose A, AX will be along this direction. This is minus x. AY would be along this direction. This is positive y. Then for B, when you decompose it, BX will be along the positive x and BY will be along the negative y axis. Okay. If you want to add, you can displace B. This is B, the same magnitude, the same direction as we did nothing, but the bottom of B is on the tip of A. So this would be the resultant. This is how we add the two vectors A plus B. Which vector has an angle with respect to the positive x-axis that is in the range of the inverse tangent function? As you know from arithmetics, the range for the inverse tangent function usually means the angles between minus pi over 2 and plus pi over 2, which means the first and fourth quadrant. Okay, we see that B is in the fourth quadrant. A is in the second quadrant, so it does not belong to the inverse, to the range of inverse tangent function. So to add vectors, you can do that graphically, as I explained, or you can do that analytically by decomposing the vectors. If you decompose the vectors, you add the x components together, ax plus bx to give you rx, and ay to by to give you ry. Then you say r equals rx plus ry square under the square root. When you solve problems, it is important first to read and understand the problem. 50% of the effort usually in understanding the problem, because if you do not understand it right, you have small chance of getting the right answer. So you need to read, digest, comprehend, understand. It helps you to draw a sketch for the problem. Then it is good to label the physical quantities. If you are talking displacement, you are talking velocity, it is helpful to label the diagram with the proper variable. You identify from the text of the problem, you identify the given variable to you. Then you know how to relate these variables. You need to choose the right equations to plug in the numbers and do some algebra to solve the equation. Once you have the answers, you check them whether they make sense or whether they are nonsense. So it's a good and simple strategy, but my advice to you, try to solve as much problem as you can in physics by solving problems. This is the best way to learn physics. You need to practice solving problems as much as you can. So in this chapter, we learned about the standards of length, mass, and time. We learned about matter. We learned about measurements in general. We learned about few techniques that we use to check on things like dimensional analysis. Any equation to be correct, the dimension both left and right sides need to be the same. We learned about significant figures, how we represent the results for any measurement that we do. We learned how to convert between the systems of units and how to estimate the order of magnitudes for our results. We learned about coordinate system that we need to describe the location of any object, whether it is at rest or whether it's in motion. We learned about the Cartesian coordinates and the polar coordinates. We learned how to go from one system to another. So here, x is r cosine theta and y is r sine theta. This is how we move from polar to Cartesian coordinates. We also reviewed the basic trigonometric functions, the sine, the cosine, and the tangent, also the Pythagorean theorem. We learned about vectors, how to add them, how to subtract them, how to multiply them, and divide them. We are done with this chapter. So if you have any question, I would be more than glad to answer it.
The question.
You have access. Yeah, you can all talk freely and ask. Yes, please. Any question?
Yes, I have questions in regards to, I guess, the trigonometric identities. Is there a resource to look at and review some of those? It's been 2 years since I've taken trigonometry, and with doing the discussion post and the quiz, I realized that I was struggling to remember some of the more complex trigonometric identities.
Okay. My policy in this regard is not to overwhelm my students. I don't want you to feel overwhelmed with any subject. After all, I am interested in the physics concept more than anything else. So if you send me an email, I can respond to that email with suggestions for reference. But in general, I will use Google search. I will put the keywords for the thing that I'm trying to learn. And there, usually, I try to use the simplest. Don't go to the websites that are very complex, very involved. Okay? The fundamental quantities here, you have sine squared plus cosine squared of any angle is 1. This would be a fundamental trigonometric function. Then you have two other functions that are important, which is sine twice the angle and cosine twice the angle. So if you just put on Google search the keywords review of basic trigonometric functions, Okay, you need just the basic. You don't need to dig deep in that subject. I know it's a fascinating subject, but it's not the thing that we are trying to learn in this course. You need just the basics.
Okay, thank you.
My pleasure. Any other question?
So for the lab assignments and the quizzes, are they have like a specific due date?
Yes. We have
Yeah.
8 chapters. Each chapter has a quiz. So you are expected to answer the quiz. Each quiz has 10 multiple choice problems. I expect you to post only the answers. I don't need to see your solutions, your detailed steps. I need just to see your final answer. So if you download the quiz from the weekly lesson, like week 2, we will have quiz there, for example, then answer the problems and post the table which has the numbers of the problems. Just fill in your answer. If you have difficulty in filling in the answers, it's okay to use your handwriting and then take snapshot. Okay?
Okay,
That should do.
like I just like because since we're like starting a little bit late, does the week 1 has a specific due date?
Yeah, I moved the due date. The due date was last Saturday, so I moved it to be with week 2. So there will be a little bit some pressure on you the first 2 weeks, but we need to catch up because the university calendar does not wait for us. Now, in my capacity as instructor, I will accept your submission up to week 3. So if you are late submitting assignment for week 1 or week 2 until week 3, that's fine. You will not be penalized for late submission.
Okay.
So I expect you to work hard, to take things seriously, and I expect you by the end of week 3 to be on phase and to be on schedule with the university. Okay?
Thank you.
Yeah, my pleasure.
I just have a clarification question. So can you just go over exactly like what we need to have done by the end of this week?
Week 2. This is week 2, right?
Yeah, because I'm looking at the schedule right now.
By the end of week 2, if you check the announcements for week 1 and week 2, I expect you to finish the things that are listed in the announcements for week 1 and week 2. But another way to check, the simplest way to check to answer your question is to go to the calendar file. If you download the calendar file will tell you exactly what things are due each week.
Okay, and I just have that pulled up, and that's what I wanted. So
Yeah.
so it's quiz 1 is due by this week, or is due, and then quiz 2,
Yes.
lab 1, discussion.
Now, the lab report, this is one thing that I'd like to clarify, because I know that none of you or most of you do not have your lab kits. The first lab is about error analysis. For this lab, you need no materials. This lab, you need just to understand what do we mean by errors. So I ask you kindly to download the handout from week 2 materials. If you open the weekly lessons, go to week 2 folder and click on the link for the lab. That's the first lab, error analysis. You can download the handout for that lab. So you will read, you will understand, you will answer questions, then you will prepare your report. When you prepare your report, I expect you to apply the structure and format that I have in the sample lab report. Okay, you need to learn how to report about your work in a professional and scientific manner. This is part of your learning experience. So I posted a sample lab report precisely for lab 1 that I expect you to imitate, okay, as you learn. So you can do that instantaneously, because you don't need any material from the lab kit to do lab 1. Okay. Then for lab 2, for lab 3, and so on, you may need some materials. In that case, you need to wait until you get your lab kit. Now, if your lab kit was late because you did not get it, say, by the end of week 2 or week 3, that should be all right. You don't need to worry. I will not penalize you for that. I understand it's not your fault. But once you receive your lab, say by week 3, by week 4, I expect you to be in phase and to complete the labs that you missed. Okay?
Okay.
You can always count on my understanding and support. I am here to serve you, to teach you, to lead you to success, to lead you to achieve your academic goals. Okay? So this is my role. Your success is my success. Okay? You just to ask, you need just to put me in the picture, you need just to tell me what you need, and I will do my best to help you. Whether it's the lab, whether it is the other assignments, okay? This is the way we move. You are welcome. So each week, there should be a lecture like this to review the chapter for that week. If we need more than that, we can always schedule additional lectures. But now, I assume the same time is good for all of you. If someone missed the lecture, that's fine. You can find it recorded on Blackboard Collaborative Ultra, so that's not a problem. But I can see that this time seems to be convenient for most of you. So we will fix this time each Wednesday, 4 o'clock Eastern Standard Time, to go over the chapter allocated for that week. It's better than starting Saturday or Sunday, because this way you will have 3 days to read, to understand, to review on your own, and then we will come together for this session so that if you have any questions, anything that need to be clarified, you will have a chance to ask me. Okay? Any other question or comment?
Yeah, I have a question for the times. Is it going to be due at 11:59 p.m. on the day that it's due?
This is generally true.
Okay, thank you.
Yeah, you're welcome. Any other question or comment? I appreciate all what you are doing, and I understand that the transition from ground classes to virtual environment may not be easy for those who are coming from the ground classes to us, but I'm sure within 1-2 weeks, we all will be doing well and moving fine. Thank you all. Now we conclude this first session. Stay safe, stay at home, and take care. Thank you.
Thank you. You too. Have a good weekend.
Thank you. Thank you.
You are welcome.
Thank you.
You are welcome.
Thank you.
You are welcome. Take care.